Hello friends, we'll be talking about polygons in today's session. So friends, let's first understand what are polygons and then we'll see their classification also. Any simple closed figure which is formed by 3 or more line segments is called a polygon. So anything like this that we make, this is a closed figure consisting of line segments. So these are all polygons. Now why 3 or more? Because 2 line segments cannot be joined together to form a closed figure. Now such closed figure with n sides is called n-sided polygon, and we have special names for some of these. So if we have a 3-sided polygon, we call it a triangle. 4-sided polygon is called a quadrilateral. 5-sided polygon is called a pentagon. 6-sided is called hexagon. 7-sided heptagon. 8-sided octagon. 9-sided nonagon. 10-sided decagon, and so on. So friends, let's now understand what are the diagonals of the polygons. So a line segment connecting two non-consecutive vertices of a polygon are called diagonals. Say for example, we draw any 4-sided figure. So if we join the non-consecutive vertices of the polygon, we get the diagonals. So if we have, instead of say a 4-sided, now if we draw a 5-sided figure, again if we join all the non-consecutive vertices, we get the diagonals of the triangle. Now the consecutive vertices are joined to form the sides of the polygon, and the non-consecutive vertices connected together will form the diagonals of the polygon, and there will be multiple polygons formed depending upon the number of sides of the polygon. So now we'll see what is the relation between the number of sides of the polygon and its diagonals. So that formula is n into n by minus 3 by 2. So this formula gives us the number of diagonals that can be formed in any n-sided polygon. Now say for example we talk about a triangle. Now triangle is a 3-sided polygon, and we see that all the 3 vertices are consecutive to each other. So there is no diagonal possible, and if we place 3 in this formula also, we get the number of diagonals to be 0. If we make a 4-sided figure, which we've drawn here, a quadrilateral, we see that n being equal to 4, we get the number of diagonals equal to 2. And if we have n equal to 5, we can see the number of diagonals become 5 into 2 by 2, which is 5. So we should have 5 diagonals in a pentagon. So if we see this pentagon that we've drawn, we can see one is this diagonal, second diagonal, a third diagonal here, a fourth diagonal here, and this is the 5th diagonal. So we get 5 diagonals in case of a pentagon, and similarly we can find the number of diagonals for n-sided polygon. So friends, let's now understand what are interior and exterior angles of a polygon. The angle formed between 2 line segments of a polygon, which means 2 sides of the polygon, lying in the interior of the polygon, is called the interior angle of a polygon. So let's draw any polygon, and we see these are the interior angles, the angles formed between the sides of the polygon and the angles lying in the interior of the polygon. These are called the interior angles of the polygon. The angle supplementary to each exterior angle is called the exterior angle of the polygon. So if we extend the side on the outside, then this angle is the exterior angle. Similarly, if we extend all the other sides, we see that these are the exterior angles of the polygon. So these are the 5 exterior angles of the polygon, and as we say that the angles are supplementary to the interior angle. So we clearly see that the interior angle plus the corresponding exterior angle add up to 180 degrees. So they are supplementary angles. So now let's understand convex and concave polygons. So if the measure of each interior angle of a polygon is less than 180 degree, then it is called a convex polygon. So the normal polygons that we generally draw, if we see this quadrilateral that we've drawn here, or if we see this figure, so we see that all the angles here, all the angles, the interior angles of this polygon are less than 180 degree. So these type of polygons are called convex polygons. And if we see the diagonals of these convex polygons, we'll see that the diagonals lie completely in the interior of the polygon. So if we, even for this 5-sided figure, if we draw all the diagonals, these are the 5 diagonals which are possible, all of them lie completely in the interior of the polygon. So these type of polygons are called convex polygons. But if the measure of at least one interior angle of a polygon is more than 180 degree, those kind of polygons are called concave polygons. Say for example, we draw a polygon of this type. Now this is again a 5-sided polygon, but here if we see this angle is more than 180 degree. So this polygon is called a concave polygon. Now here if we try to draw a diagonal from this point, this vertex to this vertex, this diagonal we see lies outside the polygon, and so this is another condition which is met, that at least one, maybe more also, diagonals of the concave polygon may lie in the exterior of the polygon. So it is not that all the diagonals will lie in the exterior. So if we see in this case also, we have these diagonals which lie in the interior, but there is at least one diagonal which lies in the exterior of the polygon. So such polygons are called concave polygons. So let's now understand what are regular and irregular polygons. The polygons whose all angles and all sides are equal are called regular polygon. So for example, if we draw a square, this is a regular polygon because all its angles are 90 degree and all its sides are equal. Now if we draw a rhombus instead of a square, this is not a regular polygon. Why? Because its sides are equal. All the 4 sides of the rhombus are equal, but the angles are unequal. So this is not a regular polygon, while a square is a regular polygon. Similarly, we could have a 5-sided figure which is a pentagon, which could be a regular pentagon, or we could have an irregular kind of pentagon. So this is the regular pentagon and this is the irregular pentagon. So any polygon with unequal angles and unequal sides are called irregular polygon. So similarly, rhombus, rectangle and parallelogram, these are all examples of irregular polygon. So friends, let's now see what do we understand by angle sum property. each polygon can be drawn as a combination of triangles. So let's first draw any polygon. We start with the minimum four-sided quadrilateral first. So if we see, this can be drawn as a combination of two triangles. If we draw a five-sided figure, this also can be drawn as a combination of three triangles. So any polygon similarly can be drawn as a combination of triangles. Now we know that the sum of angles of a triangle is 180 degree. So if we want to find out the sum of all the interior angles of this quadrilateral, we know that it has to be equal to the sum of angles of two triangles, which would mean it is 180 into 2, that is 360. Similarly, for a five-sided figure, since it's a combination of three triangles, the sum of its interior angles would be 180 into 3, and that comes out to be 540. So now let's see how do we actually find out the interior angles of any polygon. We have a formula which can be used for finding the sum of interior angles for a n-sided polygon, and that is n minus 2 into 180. And how we come to this is very simple, because for any, as we just saw that, if we have a five-sided figure, the number of triangles that will be used to form this polygon will be n minus 2. It will always be n minus 2. For a pentagon it is 3 triangles added together. For a hexagon we will have 4 triangles added together, combined together to form this figure. So, and we just know that the angles of each triangle, the sum of each angles of each triangle is 180 degree. So we multiply n minus 2 with 180, and that is how we arrive at the formula for finding the sum of interior angles of a n-sided polygon. Now since we know this formula, we can easily find out interior angle, each interior angle for a regular polygon, which will be n minus 2 into 180 divided by n, because we know for a regular polygon all the angles are equal. A regular polygon is equiangular and equilateral. All the sides are equal, all the angles are equal. So each interior angle would be n minus 2 into 180 by n. Now let's find out the exterior angles and their sum. This is very, very important. Sum of exterior angles of any polygon is always 360 degree. Let's see how do we arrive at this. We know that sum of the interior and exterior angle at each vertex is 180 degree. So the sum of all interior and exterior angles will be n into 180, because it's an n-sided polygon. So it will be 180 into n. This will be the sum of all the interior and exterior angles. Now all the interior angles sum we know is n minus 2 into 180. So the sum of exterior angle would be the total sum minus the sum of interior angles, which would become 180n minus n minus 2 into 180. So this comes out to be 360, because 180n cancels out with 180n and it becomes 360. So for each regular n-sided polygon, we can say that each exterior angle would be 360 divided by n. So this will be the value of the exterior angle for n-sided polygon. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.